Let's start this section by learning how numbers work in JavaScript, how to convert values to numbers, and also how to check if certain values are numbers or not. And before starting this section, go ahead and open up your starter files for this section so that we can take a look here at the script.js. So as I said in the last section, in this one we will continue working on our Bankist application. Okay. Now, what's different here is that now we have actually different data. So we have only two accounts now here, and each account now has a new array which contains the dates of the movements. We also have the currency property and a locale property. All right. And so we will use this data in later lectures of this section. Okay. Then down here we have the complete application that we built in the last section. And if you want, you can go ahead and replace this entire code that I have here with your own code from the last section. Okay. What matters here is that we make the application work just as it was working by the end of the last section. All right. So again, we have the same application, only the starter data is a little bit different, but everything else is the same. And so now let's start learning a little bit about numbers. And the first thing that you should know about numbers is that in JavaScript, all numbers are represented internally as floating point numbers. So basically always as decimals, no matter if we actually write them as integers or as decimals. So we can show that by doing this. So we need a new terminal here. And so here is our application back again. Let's close this and open up the console. Give it some more space. And so you see that 23 is in fact the same as 23.0. Okay? And that's the reason why we only have one data type for all numbers. Also, numbers are represented internally in a 64 base 2 format. So that means that numbers are always stored in a binary format. So basically, they are only composed of zeros and ones. Now, in this binary form, it is very hard to represent some fractions that are very easy to represent in the base 10 system that we are used to. So base 10 is basically the numbers from 0 to 9, while binary is base 2, and so that's the numbers 0 and 1. Okay? So as I was saying, there are certain numbers that are very difficult to represent in base 2. And one example of that is the fraction 0.1. And that then results in very weird results like this. And this is kind of a classic or a running joke in JavaScript because this result should of course be 0.3 and not with all of these zeros here. But JavaScript simply has no better way of representing this number. So in base 10, 1 divided by 10 is simply 0.1. And so that's very easy to represent. But for example, if we were trying to do 3 divided by 10, then that is also impossible to represent for us, right? It would be this number here and 3 until infinity, okay? And so in binary, the same thing happens with 0.1. So we get basically an infinite fraction, and that then results in a weird result like this one. Now, in some cases, JavaScript does some rounding behind the scenes to try its best to hide these problems, but some operations, such as this one, simply cannot mask the fact that behind the scenes they cannot represent certain fractions. And by the way, many other languages use the same system, for example PHP or Ruby, and so don't let anyone make fun of JavaScript because of this. Okay? So we just have to accept that it works this way because we really cannot do anything against this. So just be aware that you cannot do like really precise scientific or financial calculations in JavaScript. because eventually you will run into a problem like this. So point 2, which will result in false, which of course is incorrect, as we know. This should be true, but, well, this is simply an error in JavaScript that we have to accept. Okay? All right. Now that we know how JavaScript represents numbers, let's go back to actually working with them. So we know how to convert a string to a number, right? So that's like this. But there's also an easier way, so kind of a trick that we can use, which is to, or actually this should be a string, otherwise that doesn't make much sense. But as I was saying, there is an easier way, which is simply plus 23 the string. And this works because when JavaScript sees the plus operator, it will do type conversion. So it will automatically convert all the operands to numbers. And so therefore we see 23 here in both these cases. So in this purple color, which are numbers. So this here makes our code look a lot cleaner in my opinion. And so let's now actually go to our project and replace all the occurrences of number simply with the plus sign. So here, if I save it now, the prettier extension should get rid of the parentheses here, and it does. So here and here, and here as well. And that should be it. Yeah, that's it. Great. And so our project will work the same, but the code is a little bit cleaner now. Okay, so here we converted strings to numbers, but we can also do something called parsing. So we can parse a number from a string. So on the number object, which is kind of this function here, but it's also an object in the end, remember, because every function is also an object. And this number object here has some methods to do parsing. So let's use parse int. And so here we can now specify a string, and that string can even include some symbols. And JavaScript will then automatically try to figure out the number that is in this string. All right. And so here we get 30. And this is actually a number. It's not a string. All right. Now, in order to make this work, the string needs to start with a number. So if we have something like this, then it's not going to work and we get not a number. Okay. So this is a little bit like type coercion, but even more advanced, because as we just saw, it tries to get rid of unnecessary symbols that are not numbers. And this can be very useful, for example, in this situation, where we get some kind of unit from CSS and then need to get rid of that unit. Now, the parseInt function actually accepts a second argument, which is the so-called radix. And the radix is the base of the numeral system that we are using. So here we are simply using base 10 numbers, so numbers from 0 to 9. And most of the time we are doing that, and so we should always pass in the number 10 here. Okay, so that can avoid some bugs in some situations, and you see the result here is the same. But if we were working, for example, with binary, then we would write 2, and then the result would be completely different. In this case, we cannot even see it, but let's just keep using 10 here. So this is with integers, so that's what the int here stands for. So parse integers, but there's also parse float. So number.parse float. And let's now try 2.5 rem. And so now it reads the decimal number here from our string. So a floating point number. Let's see what happens if we used int. And then we only get the integer part, right? So it will then stop here at this decimal point. but that's of course not what we want. And by the way, we could even have like some white space down here that would not affect anything at all. All right. Now, by the way, these two functions here are actually also so-called global functions. So we would not have to call them on number. So this here also works. Okay, but this is the more traditional and old school way of doing it. Now in modern JavaScript, it is more encouraged to call these functions actually on the number object. Okay, so we say that a number here provides something called a namespace. All right, so a namespace for all these different functions like parse float and parse int. But anyway, let's now explore another function of the number namespace, and that is the isNan, so is not a number. So number.is not a number. And we can use this one to basically check if any value is a number. Well, not any value, but more about that later. So for example, if we pass 20, then here we get false. And so is it not a number? False, right? So let's try the same with the string 20. And so here we also get false, all right? Because this also isn't not a number. It's just a regular value, right? But now let's try it by converting something. So for example, this string, if we try to convert it to a number, then this will be not a number, right? And so therefore it is true. So let's just do that here. So yeah, this works as well. And so you see, this is of course not a number. All right. But let's try something else. Let's, for example, divide 23 by 0. And maybe you know that dividing by 0 gives us infinite. Okay, so dividing by 0 is something that's not allowed in mathematics, and so it will give us infinity. So infinity is also not a nan, and so therefore we get false here as well. So let me just demonstrate that here. So indeed, this gives us this special value of infinity that also exists in JavaScript. And so this is not a number is actually not a perfect way for checking if a value is a number, because it doesn't consider this use case, and sometimes this might very well happen. And therefore there is a better method called isFinite. So number is finite, and let's try it with the same numbers. So here we get true. Okay, so basically this should be the opposite now of this one, because this is not a number, but it is finite. Okay, now if we try it with 20, the string, then here we get false, because it's not a number. And so this is actually better to check if something is a number or not. And I know this sounds a bit confusing, and the confusion comes from the fact that we have this weird thing here that is also called not a number. All right. And therefore I'm just telling you that the isFinite method is indeed the best way of checking if a value is a number. So a real number, not a string. All right. So let's try again this one here, trying to convert it. And we know that this here is not a number. So literally, this will be NaN, right? And so this should be false as well. And it is. And now finally, this last use case, which gives us infinity. And so it is false as well. So that's where the name of the method actually comes from. So isFinite. And so infinity is of course not finite. All right. And so this method is the ultimate method that you should use to check if any value is a number, at least when you're working with floating point numbers. So if you are sure that you just need to check for an integer, then you can use isInteger as well. So let me just write here a comment as well. So this one you should only use to check if value is not a number. So literally not a number, this value. Okay. But usually in practice, I never use this. Whenever I need to check for a number, this is the one to go. Or if I'm using integers, then I use isInteger, as I was just saying before. So we can do this. Also, this is also integer, remember. And so both are true. Okay. But then, of course, if we try this here, it will be false. Now, in our project that we're currently building, there is not really a need to check if any of the inputs is really a number or not. And so in this particular case, we don't need to go back and change anything. But it's still good to know about especially this method here. So this is your go-to whenever you need to check if something is a number or not. And going back here, the parse float function should be your go-to whenever you need to read a value out of a string, for example, coming from CSS. So then you always get this, and it's very nice to be able to read the number out of this string.